Yeah, I like to change the background, make it a little more interesting for you. Okay, today, wrap up of that use case we started last time. Just quickly reviewing what I did, if I can find it. Let me bring up my browser, which has disappeared on me. Somebody reset this machine. Oh, I had to close all my browsers. I found out that Firefox starts acting weird if it wants an update and you haven't restarted Firefox. My tabs start turning black, and I finally figured out if I just close all my windows in Firefox, then it finally comes back normal. So maybe that's a way to remind you, hey, I need to be reset. Let's go to our online course here. And also, let's see, I need to go to my Gmail, get myself signed in. So then when I go to my draw.io page, no, drive.io, yeah, there, drive.draw.io is the last thing I used for my drawing. And if we look here in our course over here, after I get logged in, you'll notice there's lots of online drawing systems available. We used Lucidchart before. Let's see, get down to my course. Here it is. There's Visio that we've been using. Lucidchart is also a nice drawing product. And I've been using draw.io, drive.draw.io here as I discovered another one. And what reason I like drive.draw is it automatically connects to my Google Drive, which I'm pretty impressed with. The free version gives me decent capabilities, and look at that, it remembers my previous files. They're stored somewhere there in my Google Docs. And here's the most recent, yeah, it looks like it's most recent first. And let's open my one from the last time. There's my lovely use case. Now, Mike, I saw, did you have little better looking stick figures than I did? Did you find a different?
I use Visio, so
Oh, so Visio has a little more blocky Android-like robot-looking guy. Okay. And I was one thing I'm a little disappointed with this program is that when I tried to do an download as, I was hoping to see Visio capability. I know with Lucidchart, uh, you can't export to Visio unless you buy the paid version, and maybe that's also a thing here, that unless you're paying for this draw.io, it doesn't let you export to Visio capability. I haven't tried seeing if Visio will know how to import any of these. It'd be interesting to try. And under advanced, uh, let's see if it gives me any other. Be curious to see whether scalable vector graphics. I'm guessing none of these are actual Visio, full Visio capable. Maybe Visio could bring it in as an image, but then from there on, you can't modify and move things around. But the advantage here is I'm in the cloud, and I don't have to worry about viewing this from any machine. I don't have to think, okay, do I have Visio installed? That's the two machines I can work from. So there's your trade-offs, and that's going to be always your trade-off as you use cloud services is, do they have the capability of a local client service? Your local services are likely to be more responsive, not dependent on your network, but more expensive and maybe require a little more management. Whereas cloud services available from anywhere need the network, but managed by whoever owns drive.draw.io. And they can always impose a fee on me and say, okay, from now on, if you want to keep your drawings for longer than 2 weeks, you have to pay for your subscription. Nice thing about this is it's pulls it right into my Google Documents that I've been using for a long time. So I can have the familiar user interface and maybe even move to my Google Docs folders. Let's see if it recognizes my Google Docs folders here. Yes, it sees my folders are there in my Google Docs account without me having to do anything special. So it's starting to be compatible automatically with my Google world, which I live in all day, my mail and all my documents. Okay, so just a quick overview then of the use case is, remember what we're doing. We're given a overhead view, management types overview of what happens in a particular activity in my system. And in the homework, we wanted to do 3 use cases, and we have the other use cases listed in that. I think I copied my notes into the assignment. Let me zip down there, and if I remember right, here is the 3 use cases we described. So this is the student registers for course, and so then you are to add 2 more use cases: instructor grades assignment, student pays bill. And see, we're not terribly fussy in the exact details, just kind of giving general, logical, sequential, here's the kind of things that happen, separate them into separate activities. The technical details can come into other diagrams modeling what happens at the course request. These arrows get turned into passing parameters between functions in the software. And those will look different depending on the language we've chosen to write our system. This is all language independent, programming language independent. So what you want to do is not be like many people are. They automatically think of a certain language as they talk about their system. They're kind of limiting themselves into a little box of only how it works in a particular language. You want to free yourself from those chains as you talk about how the system works. Then, once you have what your system needs to do all laid out, then you can, in a systematic way, say, okay, what programming language will work best to accomplish these tasks? And you might have some creative guy you've just hired say, hey, I want to do it all in Lisp, because Lisp can do everything. And you'll have your old timer saying, no, we have a large experience with this programming language, the C programming language, or dare I say, COBOL. We've got all those libraries in there, and that will be the better way to go, young man or young lady. And they'll say, no, we can do it in Java. That's what I learned in school. Everyone else is using Java. And then you'll reasonably, and maybe a manager will come in and referee and say, no, we're going to go with this. Let's make the change, because I've realized my nephew told me we all need to go with Java. So your use case gives you a general layout, and you lay out use cases. And remember, don't forget that critical part there of after doing the diagram, what I would probably do is in a little text box underneath here, just describe generally, and let me bring up the page from that. The little page describing the pieces of the use case in words. And let me sign in here and make sure, don't forget to do this part with each of your use cases. And I'm not going to be super fussy that it's exactly the perfect code or the perfect description, but some reasonable sounding description of here's what a description of what happens in the use case. If I remember right, there's like a sequence of events, a conditions. If it completes, here's what happened. If there's an exception, here's what happens. And let's jump to that description example. There it is.
I did mine separately in a Word document.
Okay, if it's in a separate Word document, just upload that together, or zip it together. Make the name be the same as the first use case, or you could put all 3 in with the same document if you want. Just say, hey, here's the use case descriptions, and we'll find that over here. No, we're not in system design yet. Where was our use case? Yeah, there we go. So let's see if I can get to that example. So here's a type describing objects. Here's our use case. There's what I'm looking for. Name your actors. If you have multiple ones, just separate them by commas. Describe in general what the use case is, like student is registering for classes. When they have successfully registered for classes, they get a indication of a report or a transcript as after the registrar has registered the student, or if it's automatic, after the system has entered them into the database. You have an alternative. If the class is full, give them options, report options, or just reject them. And some precondition, postconditions. Precondition is the student has applied and is in the system, has been entered in the system as a user. That's an assumed precondition to the registering for a class. Postcondition is successful student now is showing up in the roster for that class. So you might put some assumptions as, hey, the student's it's registered in the system, or you could call that a precondition. You could come up with other assumptions. In this particular one, they have no assumptions. And I'm not sure if they explain what assumptions are there, but that's just giving a language or a word-based description-based rather than graphical of what your use case is about. Does that make sense? So then do the other two. Now, for the fun part. Well, I think it's fun. Hopefully you find it fun. Going to now my chapter 7, jumping ahead to chapter 7 and thinking about, okay, now how do we implement a system? And the whole idea here is, some few things we want to learn is cloud computing is a big topic here in thinking of how we're going to implement our system, how we're going to develop it. And we're talking about acquisition and development strategy. What they mean by acquisition is, are we going to build or buy it? You'll hear that term a lot in system development, build or buy, and the advantages and disadvantages of building it in-house or just buying it. We're going to try to get some good hands-on experience with this whole Web 2.0 cloud computing. Very foggy terms, especially Web 2.0, and there's no, I don't think there's actually a real strict definition of what Web 2.0 is like. Okay, that's coming next. And that actually will date you if you talk about Web 2.0, because today people are talking about Web 3.0, and Web 2.0 is assumed that that's what everyone's living in right now. And in a few years, Web 3.0 will become assumed, and we're talking about Web 4.0. Again, build or buy, outsourcing options. If we decide to buy or outsource, how can we manage that? Mr. Beatty of John Deere talks a lot about basically his role has become going from like a COBOL type programmer to managing outsourced resources for John Deere with their SAP efforts, major efforts in John Deere and many other manufacturing companies like them, moving to cloud-based and outsourced. Again, describing advantages and disadvantages of build or buy, and then thinking about requests for proposal and requests for quotation, what that's all about. So let's take a look a little bit what the book mentions about having to develop a system, have a little scenario here where they're building a system, and the idea of web-based systems hosted by outside vendors. Well, web-based system isn't going to work for manufacturing. You need machines to make stuff, but depending on your product, which it could be financial services, or you're a restaurant that does provide in-house, but you're advertising on a website, you could, or for our case study, the TIM system, we could build our server, house it in-house, or have our whole TIM system be based in the cloud that we just manage or hire somebody to manage out in the cloud. And this particular, what company is this? This scenario is a Mountain View College new information system, just like similar to our TIM system. Customer service and an information system, whatever that means. That's a pretty foggy term. Will improve efficiency. Oh, here we go. A little more details. It's at the bookstores. So it's a bookstore customer service system. So you could go with square.com. Have the Squarespace website, have the Square device you connect to your iPad or phone to take your payments only by credit card. Maybe some way of buying a cash drawer system that would connect. Could we purchase all that, or do we want to build our own? I'd say with a system like this, since it's such a common type of need for a retail kind of thing, a bookstore, most likely I'd say it's worth just checking into buying something. Let's see what these guys decide. It says large organizations use web-based systems here in the conversation. This person hears from management they're not ready for the big organization approach. They want a smaller system on the college land and then maybe go to web-based later. Uh-oh, they're even thinking about building the system. I would doubt a college has much of a developer group to be able to build a system, but maybe they have the money to hire some graduate students to build it. We actually tried that at MAS one year for our cafeteria system that you scan your card for the lunchtime. We actually went through 2 versions. The first one was an attempt building it using Visual Basic. The student was, I'd say, an average Visual Basic programmer, and they quickly realized they were over their head. But it was I don't think they were asking too much for it, and the food services person quickly realized it wasn't going to be supported. After the first version was delivered, the student that had left for the summer was no longer answering phone calls. And so that didn't last very long. It was a good first try, and they actually had some ideas of what they needed. The next time around, a student built it again, and that lasted for about 2 years. The student moved back to Mexico and was getting busier and busier, and it was harder and harder to get a hold of him when there were issues, upgrades. And the software that he used that was free initially, in order to recompile, had to go to a new version, and he didn't, and the code had to be changed, and the student had built it was no longer available to do development. So that lasted 2 years till upgrades were required, and then we paid for one, and a subscription based. We're paying for it monthly, I believe. So we outsourced that. So let's get right to the software as a service and cloud-based. Just because the complexities of software and the capabilities of software services, companies are offering software services, and it's a good model for a business. They can make money because smart programmers can write the similar software for multiple people. Rather than being hired by a company, they can say, I'll build you the software, pay me to write it for you, and I can also get paid by another company. You don't have to hire me, pay me for benefits. I'll build this system for you, or our company will provide this service for you. A whole new model and an advantage for some software developers. The challenge for the software developers is people in any country, because of the internet, can offer software as a service. And depending on what company you're living in, your cost of living may be higher, and so they're able to charge half the price for similar quality software because they are smart people as well. They're able to buy computers at lower price because their economy is tougher. they're not getting paid as much, but they don't need as much to live in the same size house as you are. So it's all kind of a global economy effects. So to be in the software as a service business is kind of a cutthroat business. But if you're creative and a good programmer and you have a good company, you can survive and market not only to your country, but you can market anywhere on the internet. So it's highly competitive, and many vendors are looking for your business. Microsoft is in the business of trying to provide software as a service, and there's other software as a service vendors. But what I'm going to look at here for a kind of hands-on, quick hands-on intro is not so much the software as a service, but the web as a platform. And so I want to jump to Amazon Web Services, and I'm going to put the login link for you, if I can find it. I'll put it in the class there, but I've emailed you a login link, so you already have your Amazon Web Services. Let me bring mine up. Since I have aws.amazon.com is the login for the standard, I have sent you a specific login to an account that I created with you as a sub-user in the account. So I've sent you your login credentials that takes you to this same account. I'm going to go through the standard login with my username. And this is a quick introduction and a welcome for you to play with Amazon Web Services. Takes you to very powerful resources. Now, it can be kind of daunting at first to see all the things available to you. Let's just look at that first one, the EC2. And the two things that we are actually using here at Emmaus are the EC2, which is something elastic computing cloud, which you can kind of think of as virtual servers available for you. And the cool thing is they're free for you at the base level, at what they call the free tier. So that lets you actually have servers out in the cloud on the Amazon, in the Amazon world, the Amazon environment of servers, which may be living in some warehouse out in North Virginia. You can actually choose the area you want to have your servers live in, including Tokyo, all through the Amazon network. So it's pretty worldwide here. Eventually, it'll be Mars, Jupiter, choose your galaxy. I don't know how long that might be. But let's take a look at, well, there's Elastic Compute Cloud, and the other one that we are using here at Emmaus is S3, which is scalable storage in the cloud. We don't care about needing CPU power. We just want to be able to store things that are accessible from anywhere on the network, on the internet. And what we're storing at Emmaus on the internet is our Emmaus Online iTunes, that is available in iTunes and through the Emmaus app, the lectures that have been recorded over the last 5-6 years and then published initially in iTunes and then more broadly through the app to both iPhones and Androids. And now as we get into Distance Ed initiative, we will be making, if there's videos available, we will also be storing them out on the storage here. The only thing that's different about the storage, it's just like any disk drive on a computer, except Amazon allows you to then make public links to any data that you have stored here. You can make it private or public, and there's tons of other things that they offer having to do with data analytics and application services, secure management to access, and I'm using this to give you your logins to this same account. But tons of other possibilities that I have no clue what some of these are, like Route 53, data pipelines, analytics. I know a little bit about analytics, but knowing exactly what these are, tons of possibilities with the cloud. So you're welcome to play and explore through these, and all the basic services are free. If we find that that you've created something that's we're going to be paying a lot for, I can just close the account and delete services. So don't sign up for something here. Let's just take a look real quick here at the virtual servers in the EC2, and I think you have the capability of actually creating an instance. Let's see if you do. Go to the EC2, and let's just go through the process of actually creating a server in the cloud. Click Launch Instance, and right away you have a choice of what kind of virtual server would you like to create. The default ones have a choice of 22 various servers. Most of them are Linux servers, but I think if you go down the list, you have a server 2012 capable, and if you see free tier eligible, feel free to play with it. You see anything that you have to pay for, don't initiate those instances. But lots of options. Actually, there's more windows than I was expecting. You can actually go all the way to a server 2003 instance, but it's not on the free tier eligible. Let's, for fun, just initiate one. Let's do one of my favorites. Let's just do, where is that? I'm looking for what we're using for our current distance ed. I'm not seeing the Linux flavor that I've been using. It's probably in a different choice here. Let's just go with this Amazon Linux. Selecting this will create a what they call a micro instance. That's the free available, so we always want to use the free one. Are you able to launch an instance? Oh, okay. So maybe I didn't impose any rules on the new users. I just created users assuming it gave them admin privileges. So as we learned the different things that you users can do, I can enable certain capabilities for you. Let me try that right now and see if it takes effect right away. Because I want you to be able to review and launch a web server. So let me go back to IAM. That's the, I forget what IAM stands for. It has to do with user security, identity access management. Let me go to users. And for you, let's see, it looks like I might have to make a role first. Let's choose a role and call the role admin. And, oh, I'm going to create a new role. Sorry, I'm going to call it admin student. And that doesn't look like it. Let's say provider access. Looks like that's not the role I want. Let's do cancel. Let's go back to users, see what else I can do. Actions. Maybe I have to create a group that has capabilities. Let's try that. Let's make a group. Let's call it student admins. There we go, and a policy. And let me administrator access. That sure looks like EC2 full access. Let's at least give you EC2 full access. And I will do next step, student admin, create group. Okay, so I've created a group, student admin. Now let's see if I go put you in that group. Add user to groups, student admin. There. And to zoom out a little bit, feedback. Looks like I don't have to do a save. I think it's done it. Are you able to create instance now? Okay, so that was pretty easy. From my admin side, I can now have sub role assignment, and for now, I'll trust everyone and add you all to. Oh, it looks like I can't add you all to groups. So I'll have to one by one add users to the student admin group. you at least have the capability now to create instances once I've added you to that group. So from an management side, you can have roles assigned and groups assigned to users and give them certain capabilities within your whole cloud system. So now go ahead and go back to the instances, your EC2, and under the EC2 services, and launch an instance. When you click this, this is where you get the choice, and you can choose any of these instances. If you like Ubuntu, pick one, and you can always, once you've created it, you can always come back and delete it if you didn't like it. So there I've created an instance. Now the instance isn't running out there on the internet as a cloud-based server until I say, now launch it. Oh, and I'm going to go to the key pair. Let's see. I'm going to choose don't use a key pair, which is insecure, but for now I don't care. And I acknowledge that it's less secure. And now I see, once I've launched it, there's my little server. About 10 clicks, and I have a server running in the cloud. And it'll take a few minutes before it's finally up, and it'll show you it actually has an IP out there, a public DNS, and a public IP. I can connect to that through the public IP. But of course, I'm not going to be able to do anything with it unless I've properly set my security settings, like allow SSH into it. But I can quickly start a remote server. Now, can I see your instance? Are you running in North Virginia? Oregon. So if I go to the Oregon, I should see yours. Now, one thing I can do here, since I think this is yours, I can come here and edit Micah's server. So I won't get mixed up between yours and mine. Pretty slick. And I can actually go in here and modify security settings. There's a way to actually adjust, let's see, instance setting. There's a way to change the filter. If I can't get into it like it's, I forget.
Real time too. I didn't have to refresh or anything, which is kind of
Yeah. There's ways to actually modify its filters, and we can go over that because you want to be able to get into it. I'm not sure if by default it actually lets you log into it. And does it tell you what kind of system it is at this point? It doesn't say what kind of system it is. It just says here's its name. So when you're creating it, you have to remember, is this a Linux system or a Windows system? If it's Windows, to manage it, the easiest way to manage it would be using RDP, remote desktop, to get into it. With Linux, you could use command line or RDP to connect to your instance. So pretty slick way to get into the cloud. Now I've kind of whipped through this because I've been playing with it quite a bit and familiar with just launching an instance and what it takes. YouTube videos and even Amazon gives you tutorials on working through this. Now you could spend the rest of the semester learning about AWS because it's pretty powerful, lots of features. And it would be useful knowledge for you just knowing all the capabilities of the cloud and Amazon Web Services. But we're kind of just going to give you a taste of it. And if you find something that you've learned, feel free to demonstrate it to us. But this will give you something to play with. I've given you all the capability of actually creating elastic compute cloud instances. I can always go in there and delete them because I think you can delete each other's if you have full admin access. So try to be civilized and not delete each other's instances. But I can always go in there and say, okay, we're shutting down all the instances. I can come in there, view instances, anything that's in there, I can go to action. I can turn it off or terminate it, means erase it completely. Generally, if you're done using it, because you do pay for CPU time eventually, you don't want to leave it running forever because you have, I think, $500 of free CPU time. If you leave it running forever, you'll finally run out of your free time. Your eLearn system right here is actually running on a cloud, an Amazon Web Services cloud instance out in, I think it's based in Virginia, because there is no Midwest center when I created it. And it's a CentOS 7 Linux-based system. So that was a lightning fast playthrough of thinking of how you're going to implement a system, how you're going to develop and deploy it, with a quick taste of our cloud options. And we'll play some more with Amazon Web Services. So between now and Friday, explore and do a little of your own research what Amazon Web Services offers you. And we'll start there. A shorter class today, because we're going to go play with the firewall.